Ultraviolet. Ultraviolet.
Light has shorter wavelengths than visible light. These waves are invisible to the human eye, but some animals like bumblebees can see them. There is three regions of ultraviolet. The near ultraviolet, the far ultraviolet, and the extreme ultraviolet. Energy. Radiation is the transfer of heat by means of electromagnetic waves. To radiate means to send out or spread from a central location. The transfer of heat by radiation involves the carrying of energy from one origin to the space surrounding it. The energy is carried by electromagnetic waves and does not involve the movement of matter. The three types of EM waves that generate from the sun are infrared, invisible, and ultraviolet. Infrared can pass through things, but at the same time, it is blocked by others. Planets don't give off invisible light, but they do give off infrared. Infrared lies between the visible and microwave photon of the electromagnetic spectrum. Infrared light has a range of wavelengths just like invisible light has. Energy from red light to violet. Visible. Visible light is what humans can see. Each wavelength has a particular color. The spectrum of visible light into different colors is known as dispersion. The colors are red, orange, yellow, green, blue, and violet. The red wavelengths of light are the larger wavelengths. The heat transfer. The energy is different at a microscopic level. In a non-metal material, energy first flows into the particles of the boundary. The free atoms molecules hit all parts of the space. They attain energy much higher than its surroundings. These particles begin to move and wiggle, increasing their vibrational kinetic energy. In a metal material, the free electrons move. In the outer shell, electrons of the metal atoms are shared among atoms, and the electrons carry the energy from one place to the metal to the other. Heat transfer through metals occur without any movement of the atom. The heat transfer rate is K times A, T1 minus T2, and D. K stands for the material used, in this case bubble wrap. The A is the area of the tube. T1 and T2 are the two temperatures we recorded, and the D is the thickness.
We chose the black box with the silver tape because the color black absorbs the sun, which when given its energy from the solar panel, the water temperature then increases. All of the heat energy transfers and stays in the box, hitting the tubes and calling the temperature or water to increase.
Insulation of box and storage container. We chose bubble wrap for insulation for our tubes in the cup because the material K, the heat transfer rate, was 0.025, which has a higher rate than all the materials. The higher the heat coefficient is in the material, the more rapidly the heat transfers through the material, making water turn hotter.
Out of the two patterns, the circle and the loopy-doo, the loopy-doo was winning by 3 degrees. And at the second run, the loopy-doo won by 1 degree. The two insulators we chose was foam and bubble wrap. The bubble wrap won by 2 degrees. Tube length out of the 25-foot and the 18-foot. The 18-foot won by 4 degrees. The black versus white box, the black won by 3 degrees. And then when it was up to the silver won by 3 degrees. Silver, E.